Okay, 1121 students. A couple things we're going to do today. We're going to work mainly on the binary number system. So this is chapter 5. This is number systems. And we're going to start with, really three numbering systems that you need to be aware of. There's binary, which is 0 and 1. There's decimal, which you're used to, which is 0 through 9. And then there's hexadecimal, which is 0 through 9. And then they add some letters on to get to 16 characters. So we're going to go through each one of those. We're going to learn how to convert and configure between those different numbering systems. So one of the first things we're going to learn about as far as binary is how to count in binary. So if we were to give you a value like 4,732, and this was like third grade, and they said, hey, break that up into the different parts that you have. So you would say, okay, well, the 4 is in the thousands column, so that's 4 times 1,000, because that's the 1,000th column there. That's the 1,000 column. And then it would be plus 7 times 100, because that's in the 100th column. And 32, that would be 3 times 10, which would be 30 plus 2 times 1, which would be in the ones column. So we have a ones column, a tens column, a hundreds columns, and a thousandths column. And when we do that, we can get in decimal values with 4 digits between 0, which would be 4 zeros, and then 9999. So we have 10,000 combinations in decimal for 4 digits. Now, let's roll backwards from 10 digits and let's roll into 2 digits. So if we start looking at this in 2 digits would look like, I'm going to change the color of this pen because I don't love red. It's not my fave. I'm going to change it. Let's change it. Let's just go back to straight old black. And let's think about a two-digit system. So if I had a 0 in the ones column or a 1 in the ones column, that would be 0 or 1. So 0 would be equal to 0 and 1 would be equal to 1. And there's no difference from anything that you've learned in decimal into the very single column of this particular binary value. So if I wanted to count to 2 with binary, the next value that I would have to be equal. We want it to be equal to 2. So 0 equals 0, 1 equals 1, and then we get to, gosh, we're out of digits. So the next thing we're going to do is just add a digit. Just like we go from 9 to 10, we're going to go from 1 to 2. And now our second digit, instead of being the tenths column, is the twos column. So I'm going to change colors again and just write the columns above the top. This would be the ones column. So if there's a 1 in this column, it's a 1, and in the second column, if it's a 2, if there's a 1 in that column, then that would be the twos column. And that, I don't know why, this keeps beeping. Hopefully it's nothing bad. That would give us 2. So now, how are we going to get to 3? Well, we've got a 1 in the twos column, and a 1 in the ones column would get us to a value 3. Make sense? Hopefully. And at this point, we've exhausted all of the combinations with 2 digits. We have, well, really, you don't see 0, 0, but 0, 0 would still be 0. And 0, 1 would be 1, and 1, 0 would be 2, and 1, 1 would be 3, and there's no combinations left. So what are we going to do? We're going to add another column. And we're going to reset the columns that we had previously, just like normal. And that's going to be a 4, and that means that the next column that we set is your 4s column. That's your 4s column right here. And so that's 4 plus 0 plus 0. And you guys can figure out the rest. Well, I'm going to go ahead and start writing it in. So hopefully this is making sense so far. 4 plus 1 would be 5. And 4 plus 2 would be 6. And 4 plus 2 plus 1 would be 7. And oh no, once we get to all ones, it's the same as getting to all nines. You got to add another digit. So we got to add another digit, and how much is the value of that digit going to be? This is a recording, and I can't hear anyone. So, right, the value of that digit is 8. It's going to be 8. Okay. So we're going to put an 8 right there in the 8s column, and we're going to just go ahead and just scroll down just a wee bit so we can get the rest of this in here. And we've got 8, and then if we wanted to go from 8, whoops, let's get out of blue. Let's go back into black. And I think I can just draw right over that one. Yeah, no one even noticed. 8 plus 1 would be equal to 9. 8 plus 2 would be equal to 10. 8 plus 3 would be equal to 11. 8 plus 4 would be equal to 12. 8 plus 4 plus 1 would be equal to 13. 8 plus 4 plus 2 would be equal to 14. And 8 plus 4 plus 2 plus 1 would be equal to 15. And that would give us a range from 0 to 15. So for four binary digits, 4 binary digits would give us a decimal equivalent of 0 through 15. Hopefully that makes sense. Now, here's the thing. So decimal to binary, or binary to decimal, pretty easy. You just have to know the column values of your binary digits, and then you can go ahead and post them. So let me clean this up over here a little bit. As my hand touches the screen, it gives us a little bit of yuckiness here. If we wanted to take anything, and let's just deal in 4 digits of binary right now. If we had a number like, well, we've got them all listed here already, but 0, 1, 1, 0, we could very easily attach those values across the top of this, and we would very easily be able to say, well, that equals 6, right? 2 plus 4 is 6. And if I had a number like 13, I could say, okay, well, 13 is a pretty good sized number. That would mean that I would have a 1 in the 8th position. So it would be 13 minus 8 would leave you with 5, so that would be a 1 in the 4th position. And 8 plus 4 is 12, and then there would be a 1 in the 1's position. So 1101, as you can see here, would be 13. You can see what I did there. I just took the 8, the 4, and the 1, where there's 1s, and I added them together. The way that you could do that is just saying, okay, here's my number. Let me erase that. It looks horrible. I could say my number is 13, and I would say 13 minus 8 equals 5, minus 4 equals 1, minus 1 equals 0. And you'll always end up with a 0 remainder, and that's a very easy way that you can go back and forth between decimal and binary numbers. Okay, so hopefully that makes sense. Now, let's add a wrinkle into this system. And it's not really that bad. It's not really that bad at all. We're going to add hexadecimal into this solution. So in a hexadecimal solution, I'm going to go ahead and add a different color again. And this is a pretty good spot for it here. We'll make hexadecimal purple just for fun. And I'm just going to write hex across the top here. So a 0 in decimal is a 0 in hex. And a 1 in decimal is a 1 in hex. And a 2 is a 2. And a 3 is a 3. And a 4 is a 4. And a 5 is a 5. A 6 is a 6. And a 7 is a 7. And an 8 is an 8. And a 9 is a 9. But then our hex digits start to change, because the idea of hex is that we want to very efficiently display bits or bytes of information very quickly. And if we wanted to look at 4 bits at a time and just use a single character, the perfect system for that would be hexadecimal, because there are 16 combinations of 0s and 1s in 4 binary digits from the beginning to the end, from 4 zeros to 4 1s. That's 0 through 15, and you can very easily get there. So instead of using 2 characters, and when we get to 10, we're just going to start using the alphabet. And that will allow us to use, in hex, 0 through 9. In in decimal numbers, and then we'll just use the letters A through F to be the equivalent of 2-digit decimal values for 4 binary digits. So 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, 15 is F, so on. That's it. That's the whole system. So usually in hexadecimal, and we're going to go ahead and scroll down a little bit more. Usually in hexadecimal, what you end up with is 2 hexadecimal values right next to each other. So let's kind of put some binary out there. Let's do a couple of these. Excuse me. Sorry. Okay, so let's do a couple of these. So let's take a hex value, or a 4-digit binary value, and then put it next to another one. So let's just go with 1 1 1 0 1 0 0 1. Okay. Now, to turn this into a hex value is very easy to do. The thing is, 1 hex character equals 4 binary digits. And what we have here is we have 8 binary digits. So what we're going to do is we're going to take them uniquely, and we're just going to draw a line right down the middle. And we're going to look at this one, and we're going to say, on the right-hand side, well, that's 8 plus 1, right? I have a 1 in the 8s column and a 1 in the 1s column, and 8 plus 1 is going to equal 9. Great. And then over here, I've got a 1 in the 8s column and a 1 in the 4s column and a 1 in the 2s column, and that's 8 plus 4 is 12 plus 2 is 14, and 14 turns into the letter E. I hope this is making sense for you guys. And that's how you can convert a byte of information into a hexadecimal value. Because you got to keep in mind what you're trying to do here. You're trying to efficiently display a byte. So whenever you see 2 hex values next to each other, like this, like E9, what does that represent? That's 1 byte of information. It's 4 plus 4 binary digits. So it's 8 binary digits next to each other. That's what that's representing. The number on the left is the 4 digits on the left half of the number, and the number on the right is the 4 digits on the right. Now, when we go from binary to decimal with 8 digits, it gets a little bit more complicated. So let's take that same number again, which was 1 1 1 0 1 0 0 1. And what we've seen so far is we kind of have an idea of what to do here, because we've seen this already. We know that the very first digit is the 1, and the second is a 2, and the third is a 4, and the fourth digit is for 8. And in hexadecimal, when we do that, 1, 2, 4, 8, we split it, and then we start over again, 1, 2, 4, 8. But in decimal to binary, we'll actually continue on here to make larger numbers. So we're going to go 1, 2, 4, 8. You see the pattern, and then there's a 16, and a 32, and a 64, and a 128. And guess what? It doesn't get any worse than that, because this is it. This is all you have to do in order to convert a binary digit into decimal, is just look at where the 1s are at and just add all the numbers together. So hex is actually a little bit easier. So I kind of gave you that one first. And then binary into decimal is as easy as, in this case, it would be 128 plus 64 plus 32 plus 8 plus 1. And if I added those together, that's 192, that's 224, that's 224 plus 8 is 232 plus 1 is 233. So if we wanted to see all of these together, we would say 11101001 is equal to 233 in decimal, and is equal to E9 in hex. Cool? Hopefully that makes sense.